ULTRATRX Electric Bikes hired me to be in charge of their engineering and their design of their new models of fat tire electric bikes. And their bikes are designed for backcountry, hunting, fishing, and also, just going back into the woods and exploring, or going off-road into the, onto the beach, through deserts, wherever, backcountry, wherever you're just out. And so they wanted the best bike for that. And so they hired me. I have a degree in physics, and I have the expertise in the bicycle industry and the electric bike industry. I have expertise in engineering, electrical engineering, manufacturing, and logistics. I started in 2008 building the second fat tire regular bicycle. To be an expert in the electric bike industry, you need to be an expert in both the bicycle industry and the electronics. And so I started in 2008 manufacturing a fat tire bicycle. And so when we first started out, the tires were 4 inches wide, and all your bottom brackets, all your other parts were made for smaller tire bikes, mountain bikes and cruisers and things like that. So they were set really to only go maybe 2.5 inches wide. So once we went with the fat tires, which are 4 to, they've gone as high as 5.5 inches, we had to make a bigger bottom bracket. So I personally designed the new bottom bracket that almost everybody uses in the electric bike industry, fat bike industry. I designed it with a solid steel axle that's heat treated. The axle is 168 millimeters long, and then I designed it with a shell with sealed bearings in it so that you don't have the problem with the bearings rusting and things like that in the future. And so I designed that bottom bracket. Now almost everybody in the industry uses it. Didn't put a patent on it, but that's irrelevant. So then I went on and designed a rear hub, because you had to have a wider rear hub to get the chain past the wider wheel. So we designed a rear hub. We first started with a 170 millimeter rear hub, then we went to 190, then 197. That's pretty much where we're at right now, about 197 millimeters in the rear hub with the cassette and everything. And that allows you to clear the rear tire up to about 5 inches. We had to design a wider front fork, so the fork would fit the wider tires. And so we ended up with a 135 millimeter dropout in the front fork. So all these things we went through in the design of the fat tire bicycle part of the bikes. Once we reached a point that we had perfected, we thought, the fat tire bicycle, we went ahead and designed a wheel system, which was the fastest wheel system in the world. We used rims with cutouts, which I have patents on, and we made them carbon fiber. We made them 29ers, so they were much bigger than a normal 26. And then we used a low wall tire that we tooled and manufactured. And so we made this carbon fiber with carbon rims and really lightweight tires with low walls on it. And we said, you know what? Let's go out and break a couple world records with it. So we did it for a charity. We did it for kids with autism. And the rider was a guy named Michael Unklespay. And in April of 2014, we broke 2 world records on Daytona Beach. In 2012, because most of what we were doing at that particular point was beach riding, we found that it was really hard to take a fat tire bicycle and get it started in soft sand, because once you got on the bike, you had to get that back wheel moving, and you couldn't get the back wheel moving in soft sand before you fell over. So I said, hey, let's put a motor on the front. So in 2012, we made the first electric fat tire bike. And we put the motor in the front, and the reason why we put the motor in the front is it gives you 2 effects. It gives you power in the front and power in the rear if you're pedaling, number 1. Number 2, the automotive industry proved that having a motor in the front in soft terrain like sand, snow, ice, mud, you name it. Also, when you're going over rocks and things like that, it's always pulling you up and out of whatever indentation you're making, always pulling you in whatever direction that you're going. So we put the motor in the front. It took us about 3 years for everybody to really catch on that that was the way it needed to be in the backcountry, to be off-road with the bike. In 2018, we designed the first dual motor fat tire bike that had both a motor in the front and in the rear, and also had 8-speed cassette, so it also had a derailleur. It had gears, so it also had a derailleur with gears and shifter, everything that you need. So what happens is that we took all of the best of the bicycle industry, and then we started putting into the electric bike industry. And we slowly progressed with that to the point that we are at today. We have come out with really the best design of any fat tire electric bike in the world. So what we've done is that we've done a dual motor system, and we use a hub motor. Now, there's many people that feel like the mid-drive is the way to go. There's companies like Rambo, Quiet Cat, Baku. There's even more companies that use it. There's a company now that sells one for $18,000, which is OptiBike. And so they all use a mid-drive. The problem with a mid-drive is twofold. First of all, it's pushing the rear wheel. So therefore, the front wheel has no traction. So if you get into soft terrain or you hit rocks or whatever, that front wheel wants to turn to a 90 degrees and wants to toss you on the ground, which is very dangerous. And people don't look into that danger. But you've got companies like Quiet Cat that have gone into business with Jeep. So they're in business with an automotive dealer that has to deal with thinking about accidents and stuff like that because they're in the automotive industry. And I don't believe they've really looked into this mid-drive situation because it really has a lot of dangers. It has the danger of the front wheel getting locked and throwing the rider on the ground. It has the danger of it puts too much torque on the chain. The chain's only made to take 2,000 pounds of torque. It could put up to 6,000, 7,000 pounds of torque on that chain. And therefore, there's so many things out there on the internet that you can look up on your own that show the chain snapping. When the chain snaps, a couple things can happen. Number one, you could be 30 miles back in the woods and you're gonna have to walk home. Or say you've got an extra chain with you, so you repair the chain. Say it breaks again, same thing. You could be 30 miles in the woods and have to walk home. The other thing is when the chain breaks, it could wrap around the back. If the chain breaks, it could wrap around the back gear system and it could stop the bike cold and toss you on the ground. Also the derailleur itself, it's going through the derailleur, so the chain is being pushed by the motor, going through a derailleur system. If the derailleur is not tuned perfectly and it overshifts, it goes too far off the top or too far off the bottom, it will lock the back system up in a different way, and at that point does the same thing, locks the bike up, could toss you on the ground. The last thing is debris. If you get debris into the chain and it gets into the gear system, again, it can lock the bike up and toss you in the ground. So there's multiple things that happen, and if that happens when you're deep in the woods and say, you hit a rock or whatever when you fall off, it could be very dangerous because if you're 20, 30 miles into the woods because of the batteries giving you the ability to go really further nowadays, you could have a very, very serious situation that we don't want our customers to have, and we really would like the manufacturers and even Jeep to look into the factor that they may be putting something out there that could endanger their customer and to the point of endangering their life. I mean, you're 30 miles back, your phone's probably not going to work. There's all kinds of things that could happen. So mid-drives are really not the solution to the fat tire bike industry. The solution to the fat tire bike industry is hub motors, because no matter what happens, I could take this chain on the bicycle and I could throw it in the garbage and the bike's still gonna go. So the other thing that we did, which we have patents on all this by the way, was that we took the hub-driven motors, there's two of them, and we turned it into two systems. Now other people have copied and other people have are doing dual motor systems now. but they're using one controller, one system. So if any part of that system goes down, if the controller goes down, or your display, or your throttle, or any part of that system has an issue, you're going to lose both motors. You're going to lose the ability to have electric motors. Whereas ours are two separate systems. So we have two controllers, we have two displays, we have two throttles, we have two motors. Any of those have any problem whatsoever, well, you still got the second system to get you home. So if you're deep in the woods and you have a problem with one of those issues, you still have that second motor to get you home. The other thing we've done is that we've made all of our systems plug and play. So therefore, when you've got all the other people, electronic systems have a bunch of low voltage wires, high voltage wires, all of this just plugged into a controller. All of ours are waterproof plugs, and they're either color coded or they're size coded. And there's only, on each of our controllers, there's only 5 plugs. And those 5 plugs go to the motor, they go to the lights, they go to the throttle and display, they go to a cutoff for on the brakes. You know, they go to different places. But if that controller, the brains of the bicycle, breaks, you can call our company up, you can call ULTRATRX up, and you could say, hey, I'm in Illinois in the middle of nowhere, and I want to keep my adventure going. I want to keep in the back. I want to keep in the back country. I want to keep in the back country. I don't want to leave. What can you do? Well, we can overnight you a new controller. You can unplug the other one yourself. You don't need to take it to a bike shop. Plug the new one in, it's fixed. Display goes bad, same thing. Take a plug, unplug it, plug a new one in, it's fixed. Throttle goes bad, unplug it, take a plug a new one in, it's fixed. Every one of those things are the same. Our motors have the same structure. The motors are set up with 6 bolts. You take those 6 bolts out, it's a cartridge inside of it. You tap the axle with a rubber mallet, the whole cartridge slides out, you slide a new cartridge in, you put it back on the bike, it's fixed. Simple. So we've done everything you could possibly do to make this bike invincible and make it simple. And then we took all my math experience and everything, and we made sure that we got peak out of every single item that we're designing and we're developing. So the big thing that everybody's talking about is that you've got to look into watt hours. Watt hours is mathematically calculated. Watt hours is amp hours times the number of volts of the battery. The watt hours on the 2 larger bikes, which is the E-Grizzly and the E-Terminator we have, are 2,640 watt hours, huge. The watt hour on our folding bike, which is the E-Buffalo, is 1,680 watt hours. We took our bike and we drove this bike until it quit. This bike got 97 miles total. Between the 2 batteries on the front, there's one on the top here, one inside the frame, one in the rear, okay? On our folding bike, it has one inside of the frame and one on the rear. So we got 97 miles out of this bike. That was averaging about 20 miles an hour with no pedaling whatsoever. The rear battery, we got 47 miles out of the rear battery on both bikes. The front 2 batteries, we got 50 miles, 50.4 miles out of both of the front 2 batteries. The front battery on the folding bike, we got 20 miles out of it. If you're using the optimum motor, which we're using 1,000 watt motors in the front. That 1,000 watt motor has a 30 amp controller. So if you've got 2 of those 1,000 watt motors, to get peak power out of that motor, to get peak watts out of that motor, and to get peak torque out of that motor, you've got to push 30 amps into each of the motors. You have to push 30 amps into each of those motors. Most of the batteries that are being made will only put out 30 amps. It's called battery maintenance system, BMS. Their BMSs are 30 amps. Okay, so these people are building bikes with 30 amp BMSs when the motors want to take 60. They can't give it to them. So you're not going to max out what the bike can do because you don't have enough. You're not going to max out what the bike can do because you don't have enough amps coming out of the battery. You can have a 48 volt battery, you can have a 52 volt battery, but if you don't have enough amps coming out of that battery, it won't peak out what power that these bikes can really go. Our bike, if you peak at 30 amps, mathematically, the number of watts is watts are amps times volts. So if you got 30 amps and you got 48 volts, the peak power on this thing is 1,450 watts on both of these. So it's 2,900 watts you could get peak power out of this. You can get 180 Newton meters of torque. Each one of these motors will push 90 Newton meters of torque. So you can get 180 Newton meters of torque. We have videos showing this bike climbing a flight of steps. I mean, climbing up a flight of steps. How many bikes will do that? None, okay? A lot of them will go down, but none of them will go up a flight of steps. Nobody shows you this in videos. Nobody proves the distance the bike will go. Nobody proves the power that the bike has. Our bike has more power than any other bike made in the industry. Our bike has more amp hours than any other bike in the industry, which means it has more watt hours than any other bike in the industry. And it will go further than any other bike in the industry. First, I'd like to talk about the new design that we just have patent pending on, is that we took a disc brake rotor, like this one, and we used a 203 millimeter rotor. And what we did is the outside edge of the rotor, we made marine grade stainless steel. Stainless steel comes in two grades. One's 15.5, which is standard stainless steel. One's 18.8, which is marine grade stainless steel. So we took marine grade stainless steel, which will not rust at all, no matter what. And we made the outside edge out of marine grade stainless steel and the same thickness as a normal rotor so that your caliper can grab that and stop the bike. We made the very center of this out of marine grade stainless steel so that when it bolted to the bicycle, it would have strength in the bolt. And then in the center, we made it out of aluminum. And the reason we did that was we put magnets all the way around this, and we have two coils set up, one on each side of this rotor. And so as the front and the rear rotor are rotating, they're creating power. And that power is going into capacitors, and the capacitors are then converting it into volts. And so the capacitor will be converting it, if it's going into a 48 volt battery, the capacitor will be converting it into 54.6 volts, about 2 to 5 amps of input. And so you're going to get, by having these rotors with the magnets and the coils, you're going to get a generator system that's constantly generating power back into your batteries the whole time you're riding. That's going to give your battery about 30% more distance than you would have gotten anyways, because you might as well use it and let these things that are rotating make power. So we designed that. It's going to be part of this system that you can buy. We've also designed a locking plate. So what's happened is the axles on both the front motor and the rear motor, because the motors now are 1,000 watts, but they peak out at 1,450 watts, and they throw 90 Newton meters of torque each, so 180 Newton meters of torque. They're throwing so much torque, and the way it's designed is that this axle is locked into your dropout. So that's what's supposed to keep it from rotating. But there's so much torque there that at some point it will wallow out your dropout. It will wallow your dropout out and possibly allow that axle to rotate, rip the wire straight out of your motor. We've designed locking plates to lock the axle in your motors. Locking plate that locks that thing into place and bolts into your dropout so that there is no way possible that axle can rotate. We've got the same on the back. It's one right here. See how it's bolted into the bike? It cannot rotate. The other thing that we're doing is that all these bolts that are made from every single manufacturer in the bicycle industry use 15.5 stainless steel. So every one of these bolts, if you see them, these have been out in the weather, okay? They start to rust, and it will rust where you put your Allen key. And so What we've done is we've had our people that are assembling the bikes pull all these screws out, all the nuts, all the bolts out of the bike and replace them with 18-8 marine grade stainless steel, which will not rust. Nobody in the industry does this. And that's why our bikes will last forever.